this room in here. Just enough for two in here.
Hello and welcome to the concepts video on linear functions. So let's start with the basics. So we have a linear equation, and I'll abbreviate equation. So a linear equation has the following form. Has the form of f of x, that's an x there, is equal to mx plus b. Okay, where m and b are constants. Alright, so where m, and b are constants. And constants just mean whole numbers. Or not whole numbers, but just like real numbers and yeah, like normal numbers, non-variables. They're not changing because they're constant. Okay? And another way to write this is just a commonly seen way of writing this is just y equals mx plus b. Okay, so let's identify some things. So this x is just a variable, your input, okay, and y is your output or your f of x. Okay, the m is really important, and that's called our slope of our line. Okay, and b is called just the y-intercept. Y-intercept, and we'll see why. WHY on the next slide. Okay, so we have a form like this, y equals mx plus b. We can also denote this as f of x too. Either one works, either notation here. Okay, so basically on a graph, let's say we have something like this, and I'll just draw a random graph. So x, y. Okay, so let's say we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 1, 2. Okay, so let's say we have a graph like this. It's here, and then I'm just going to draw the line, and then I'll explain what's going on, okay? So we have something that looks like this, alrighty? And I'm going to try my best to draw a straight line, okay, as is humanly possible. Okay, there we go. We're just going to pretend that crosses this point here. Okay, so let's say we have a line like this, alright? So like I said, well, let's go in the opposite direction. So B is called our y-intercept. And let's see the reasoning behind that. So if we look at our function, let's say we have our f of x is equal to mx plus b, right? Let's see, okay, when you plug in 0, what happens? F of 0 is equal to m times 0 plus b. So this whole mx term, that just goes away, right? And the value of our function when our input is 0 is equal to b. So that means, so let me say that one more time so it can sink in. So the value of our function when our input is 0 is equal to b, okay? And that's why b is our y-intercept, because if we look at our graph, when x is 0, so meaning at this spot here, the value of our function is right here, okay? So that means this one, in this case, our b is equal to 1, okay? So in our case, b is equal to a 1. That means that's our y-intercept. When you plug in 0, that's what you get from your function, okay? Now m, that's a little bit different, okay? Well, actually a lot different. That's a completely different thing. So m is the rate of change of our linear function. And for linear functions, this is specifically called slope, okay? So basically, this is the rate of change of our function value with changes or corresponding to changes in x, okay? So as we change our input, how does the values of our function respond, all right? So we'll go more in depth on the next slide about slope and everything. Okay, so m is equal to slope, and that's the specific name for the rate of change of a line, okay? So I'll just write that down. That's pretty important. So specific name for rate of change, I'll abbreviate rate of change of a line, okay? Some linear function, alrighty? So this is basically how much y changes, or the value of our function changes, with every 1 increase in x, okay? So there are a lot of ways to interpret slope, and they all basically boil down to the same thing. So how much y changes with every 1 unit increase in x. So this is one way you could think of it. Another way, a very common way to think of it, is called rise over run. okay? And again, I'll draw a picture of this. I think now would be a good time. So let's draw x and y, okay? And I'll just draw that graph again. So we have something like this, and then 1, 2, 3, 4, 5, 1, 2. Okay, so we had a line that looks like this, okay? And we'll just draw our line here. Okay, so basically, between any points, any 2 points on the line, the slope is going to be the same, okay? That's an important thing about a line. That's what makes it linear. That's what makes a function or a graph linear. So anyway, so let's say we pick this point here, right? And let's say this point here, all the way up there. So what rise means is between those 2 points, the ones that I'm making bold right now, between those 2 points, there's a change or a difference in x. So that would be kind of like this triangle x thing. That triangle is pronounced delta. It just means change. So the change in x, there's a change in x between these 2 points. There's also a change in height, or a change in y, right? So this rise part, that's what the change in y is, okay? So rise means how much did your y change? How much did your function, the value of your function change as you ran, the run part, a certain distance? So that means like according to how much you changed your input, or your x, okay? So this is rise over run. That represents our slope, or our m. Okay, so in our case, let's look at this. So here's the point 2, 0, 1, 2, 0, 1, 2, 3, 4, and this is 5. Okay, so let's take a look at our points, all right? So we have the points 0, 1, and the other point I filled in was 2, 5, okay? So rise over run, that means how much did our y change in between there? That would be calculated by taking the difference between our 2 y values. But before we do that, we have to identify a couple of things, okay? So let me write an explicit formula for m to find our slope, okay? So given 2 points, what the formula looks like is y2 minus y1 over x2 minus x1, okay? So given 2 points, let's say this is x1, y1, and this is x2, y2, alrighty? So given those 2 points, you would just label them as such, okay? And it doesn't matter which order, because if you put them in the other order and you get a negative sign for some reason, they'll cancel out and they'll be fine. They'll equal whatever you had. It doesn't matter the arrangement, basically. You just have to pick the same ones. So this is x1, y1, x2, y2, and then you just plug it into the formula. But it's important to realize what's really going on. So again, this is the change in our y, or the change in our function values, and this is the change in our x values, okay? So if we plug them in, we get 5, which is y2, minus a 1, and then over a 2 minus 0. So this gives us 4 over 2, which boils down to just a 2, or 2 over 1, okay? So this is our slope. This means, if we look at the definition up here, or the interpretation, is how much y changes with every 1 unit increase in x. So this means a slope of 2 means that, well, our function is increasing 2 units, or 2 units in the y direction for every 1 unit increase in the x direction. And we can see that that is true on this whole line, right? So let's say we start at this point. So let me graph it real quick. So we have 1, 2, 3, 4, 5, all right? And our line looks like this, okay? And we draw our line. Okay, so let's say we're looking at this point. Again, we're going to start here at the y-intercept, right? Let's say we move over 1 in the x direction, right? So that's a 1 unit increase in x. And in order to get up to our function, we have to go up 2 units in y, right? Because this is 3 up here, and that's a 1. So, and that's the same. If we go over 1 step in the x direction, we have to go up 2 in the y direction, and etc., etc. Okay, and it also works going to the left of our point. If we go... We can kind of go backwards, right? So if we go down 2 in the y direction, that means we have to go left 1 in the x, okay? So this same thing, I know it's a little bit complicated to wrap your mind around, but let me just squish in one more tiny concept in this box here. So our slope, you know how we got m is equal to positive 2, right? This is the same thing as saying negative 2 over negative 1, right? So this would mean, if we're looking at our rise over run, right? That would mean, well, that means we go down 2, because the negative sign, right? Down 2 and to the left 1. Whenever you see negative signs, that usually means in reference to like graphs and things. Negative sign either means down or left, okay? And a positive sign just means to the right or up, okay? Okay, so I promise this is the last time you're going to see this graph, this particular one. So anyways, we found that our y-intercept is equal to 1. So b equals 1, that's because that's the value of our function when our input is 0, right? And then we found that our slope is 2, or you could also write this 2 over 1, either way, okay? So 2. So in order to plug it in and construct the equation for our line, all we have to do is plug those into this form, y equals mx plus b. We just keep the x and the y there because those are variables, right? So all we have to do is say y is equal to m is a 2 times x plus b, and that would just be a 1, and we're done, right?